watching Devaston. In this video we are going to see about electricity in detail. Let's jump into the video. Now, electric current and circuit. First, electric current can be expressed as the rate of flow of electrons in a particular area in unit time, which is called electric current. It also can be said as the rate of flow of electrons. These electrons move inside the circuit. Circuit is the place where the electricity flows. That's called the circuit. So the circuit helps the electrons flow, but the electrons aren't found when the time electricity was flowing. So they thought the electricity was flowing from the positive end. That's why they are still recognizing that the positive way is the flow of electricity takes place. If a net charge Q pass through a cross section of conductor in time, then the current in the cross section will be I is equal to Q by T, which means here I is the current and Q is the net charge and T is time. It means when the cross section is there in the conductor and the net charge is passing through that conductor in time, in certain amount of time, by calculating those we can get how much amount of current passed through that. So that's what it means. The SI unit of net charge is coulomb. 1 coulomb is equal to 6 into 10 power 18 electrons. The SI unit of current is ampere, which is named after the French scientist André Marie Ampere. This ampere in an electric circuit is measured by ammeter, which is a device which is always connected in series connection in the circuit. 1 ampere is constituted by the flow of 1 charge of coulomb per 1 second, which means 1A is equal to 1C by 1S. Now, potential difference. Before going into this topic, I am here to give you a small example to understand this concept very easily. First, now take a building. On the rooftop there are 2 tanks connected with each other. In the midway, one tank is completely filled and the other tank is partially filled, very low. When the connection between the 2 tanks has been opened, the water from the one tank moves from that connection to the other tank, and both the tanks are filled equally and the movement of the water stops. Just like that, in a connection there are two or more cells or battery or even single cell. The positive terminal and the negative terminal will be there. The movement of the charges from one terminal to the other causes the potential difference. This potential difference will be zero when both the terminals have equal number of charges. Now, if positive charge is higher in one terminal and negative charge is low, the current will be flowing in to balance this. This is called the potential difference. The SI unit of potential difference is volt, named after Italian physicist Alessandro Volta. We can define potential difference as the work done to move one charge from one end to the other end of the circuit, which means potential difference is equal to work done by charge, which also means potential difference SI unit is V and work. V is equal to W by Q, which means V represents the potential difference, W represents the work done, and Q represents the charge. Circuit diagram. There are many diagrams used to construct a circuit, many diagrams used to represent many devices which are used to fit in the circuit, and also some constituents of the circuit. Have a look at them. Ohm's law. It is quite simple than you think. Now it goes like this. Just listen to this carefully. The potential difference between the given wire, metallic wire, at the two ends is proportional, directly proportional to the amount of current flowing through it. At the temperature remains same, which means V is proportional to I, which means voltage is proportional to the current flowing in the given circuit. Now VI is equal to a constant. V into I is equal to constant. V by I is equal to a constant. Now we can take the constant as the capital R. Now V by I is equal to R and V is equal to IR. Here R is a constant given in a metallic wire at a given temperature. It is also called resistance. Resistance is used in a circuit to control the flow of charges in it, and it is also the unit of ohm. According to Ohm's law, R is equal to V by I. The potential difference of a metallic wire at both ends is 1 volt and the flow of current is 1 ampere. The resistance of the metallic wire is 1 ohm, which means 1 R is equal to 1 V by 1 A. From this Ohm's law, we can conclude that resistance is inversely proportional to current. If the resistance is doubled, the current flow is off. In many situations in the circuits, we need to have some invariable amount of resistance, so they use the component called variable resistor, which is also called rheostat. Rheostat is a device which regulates the flow of current according to our need by sliding them across to control the flow of the charge. In an electric circuit, all the electrons don't have the freedom to move so quickly at all the conductors. Some conductors have the resisting capacity which denies the electrons to move through it too quickly. So that kind of thing, that kind of metals and that kind of conductors are called resistors. They have the resistant power to stop the flow of electrons from a higher specific speed, and you can see insulators are very higher in resistance value. Factors on which the resistance of a conductor depends. Now it depends on three conditions. 1. The length of the resistor. 2. The area of cross section, and 3. The nature of the material. Now resistance is higher in the place where the length is so much and it is less in the area there is a big area of cross section, and of course the nature of the metal is also plays a big part in it. Now we can say that R is directly proportional to length by the area of cross section is equal to L by A. R is directly proportional to L by A. R is equal to rho L by A. In this, rho is the constant, which is also called the electrical resistivity. Resistivity is the nature of the material, the amount of resistance it can give naturally. The resistance between 10 power minus 6 ohm meter and 10 power minus 8 ohm meter are very good conductors. Yes, actually I forgot to tell that the SI unit of the resistivity is ohm meter, as the area of cross section and the length comes into play. It's ohm meter. Have a look at some materials and their resistivity levels. Now, resistance of a system of resistors. In this topic we are going to see what happens if resistors are placed in a combination in the same circuit. First, let's see about resistors in series. Now we have a pic that show you how resistor in series will work. In this type of the combination of resistor placement, the potential difference and the flow of current is equal throughout the circuit without any changes, which also means the potential difference in the total circuit is equal to the sum of potential difference in each resistors, which means V is equal to V in R1, V in R2, V in R3, sum of all three, V in R1 plus V in R2 plus V in R3. So in the V, R1 is resistor 1, R2 is resistor 2, R3 is resistor 3. Now when we compare that to the Ohm's law, which V is equal to IR, then if VE is equal to IR, then we can also write that as IR is equal to IR1 plus IR2 plus IR3. Now by taking that I common from all the three R's and placing it in the bracket before the brackets, the I from the left side and the I from the right side gets cancelled, and it becomes like R in the series, which means the total resistance in the series is equal to R1 plus R2 plus R3. From this we can conclude that the resistance, the whole resistance is equal to the sum of the individual resistors, and the total resistance is always greater than the individual resistance. Now resistors in parallel. Resistors can also be connected in parallel. Let's see how it's done. Now when the resistors are connected in parallel, it is observed that the total current in the circuit is equal to the current in each resistor, which means I pi, that means I in parallel is equal to in I1 plus I2 plus I3, which is equal in all. When we bring in the Ohm's law in this, I is equal to V by R, and V by R and P, the small p below that R, which means that the resistors are connected in parallel. Just for the reference, it means if we combine both things, it becomes as V by Rp is equal to V by R1 plus V by R2 plus V by R3. It becomes like this since I is equal to V by R, and also I is equal to I1 plus I2 plus I3. The combination of both these equations form this third one, that's V by R in parallel is equal to V by R1 plus V by R2 plus V by R3. Now if we take the V in all the equations separately, and the left side, V in the left side will be cancelled from the V in the right side. Now what we get is 1 by R in parallel is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Now we can conclude that the reciprocal of the equivalent resistance of the every resistors is equal to the sum of the reciprocal of individual resistors. Now we conclude that which is better, resistor in series or resistor in parallel. Now if you look at the resistor in series, it is connected from one to each other, that which one is here and the next one is here, next one is there. They are connected together without gap. If you look at the parallel, the one is here, the second one is bottom down, and third one is bottom down there. Three are going in three different paths in parallel, but in series it goes in same path. Now if you look at the negative thing in the series is, if the one resistor breaks down, the entire circuit will be failing. You cannot run that circuit even if you on the switch or change the battery. If one resistor fails, the entire circuit fails. But in parallel, even if one resistor fails, there are two other ways to go for the current through the resistor. So it's always better to have a parallel resistor instead of series. Heating effect in electrical current. We often notice that when a electrical circuit is placed, it gets heated a lot. Even if you run a fan for a while and you have if you touch it, you'll feel warm. How does it happen? It is because of the excess energy formed because of the stop from the resistance. It converted that energy, the chemical energy is converted into the heat energy. The electrical energy is converted into the heat energy and used to increase the temperature of the gadget. This is called the heating effect of the current. This heating effect of the current is used in many ways, like water heaters, iron box, etc. Now consider electric current I passing through a resistance R. In this, the potential difference is V and the charge is Q. The work done to push the charge from one end to other end in time. Let's take the time out. The work done to push the one charge from the one end to the other is VQ, because it's potential difference which is required to push push the charge from this end to this end, so it is VQ. When it comes in time, gets divided by time. Let's take P as the source of the energy, which makes P is equal to VQ by T. VQ by T is also equal to VI, which means the potential difference, the product of potential difference and the electric current. When they push the T from this place, T pushed to the P, which makes P into T is equal to VQ is equal to VLT. If P is pushed from this end to there, it also goes to the other end, which also makes it VLT. Now, where does the expanded energy go? That expanded energy is moved as heat energy. So the amount of heat energy is extracted can be written as H is equal to VLT. That VLT is the expanded energy and that is the energy which gone out as the heat energy. Now if we take it as consider it compare it with the Ohm's law, which is converted into H is equal to I square R and T. The V is equal to I by R, so when it is in the product change, the I becomes square and R gives a company to it, along with T, which came from the stays from the beginning, which means H is equal to I square R T. Second point, directly proportional to the resistance of a given current. Third point, directly proportional at the time on which the current flows to the resistor. Practical applications of heating effect of electric current. Heating effect of electric current is used to a great extent in practical world. Some examples we can see are electronic laundry, dryer, hair dryer and iron box, and also the water heater, etc. It is also used for making a bulb glow. It requires a solid and strong metal which can stay unmelted even at a very high temperature, like tungsten. Tungsten melting point of tungsten is 3380 degrees Celsius. It requires to burn as much as it can. For that, the bulb is surrounded with inactive nitrogen and argon just to support the lifetime of the filament. Another practical use of the heating of electric current is the fuse. Every home has fuse which used to cut the current when there is an excess amount of current flows through the wires. The fuse wire gets melted when excess amount of current flows through it and breaks the circuit, therefore avoiding a big electrical disaster, etc., like firing in home, short circuit, etc. Electric power. We already saw in the Joule's law of heating, in that we saw the formula H is equal to I square R. It also referred to P because P is also equal to that value. So P power is also equal to I square R, which is also equal to I is equal to V square by R. The SI unit of electrical energy is watt. Since watt is a very smaller amount of energy, kilowatt is used for commercial purposes. 1000 watts makes 1 kilowatt. Now, as the electrical power is a product of power and time, it is usually called as watt hour. But it is commercially we use the term kilowatt hour, which also called as unit. 1 kilowatt hour is equal to 1000 watt into 3600 seconds, which means 3.6 into 10 power 6 joule. Now that is the relation between the commercial unit of energy and the actual unit of energy. Okay guys, that concludes the video. Don't forget to leave a like and share for this video, and if you want more videos like this, please subscribe to Davis John and wait for the videos to come up next. And if you really want to give feedback on my videos, don't hesitate to place it in the comment section. I like to rectify my mistakes. Until then, see you. Bye bye.